Hey guys, welcome to this video lecture series on the subject of polymer science and technology. I'm Harsh Panchal, Assistant Professor in Chemical Engineering Department of LJ Institute of Engineering and Technology. In previous video, we have started the addition polymerization, in which we have seen the free radical polymerization. And we have said that any polymerization process, specifically addition polymerization, involves three steps. The very first one is the initiation, then it is followed by propagation step, and last we have termination step. Well, initiation and propagation are already discussed in a previous video. If you have missed that video, you can find it in the I button over here. Now, having said that, let's just move to the termination process. Well, before discussing termination step, we need to just brief about initiation and propagation step. In initiation step, substance we call that the initiators are decomposed into the free radical form, and they can easily attack on any monomer and they can form one pair of bonds so that they will form one initiator monomer. Now, whenever this first initiator monomer will come in a contact with fresh monomer, it will try to link with each other and it will transfer its free radical or free electron to the last carbon of the molecule. This is what we have seen in the polymerization process and in the last video. Now, the third step is about the termination, in which we try to stop this polymerization process by killing this free radical generated in the polymerization process. Well, you can see on the screen, after propagation step comes the termination step, in which any further addition of monomer unit is in the growing chain is stopped. So now with the termination step, we do not allow the growth of polymer and try to arrest this polymerization process by killing the free radical. Well, how do we can do this? Well, we can achieve this deactivation of growing chain by two ways. In very first method, we try to unite this two polymer chain by combining each other. So, two growing chains are united by coupling of free electron present in each chain, and finally they are nullified their activeness. So you can see on the screen now, this is what the one first polymer and this is another chain of polymer. We try to terminate both the polymer by coupling them. So you can see that this last carbon has a free radical within it. And here in this step, this last carbon also contains one free electron. So when this two polymer will come in contact with each other, they will donate their one electron which is in their outer periphery and make a bond. And now you can see that this particular substance do not have any free radical or any free electron. So it will not undergo any polymerization process. So let's see how this actually happens. See here, this CH-X compound has a one free electron, and here as well this CH-X compound also has a free electron. So when they merge together, you can see here in this particular section, let me just take a pen. Here in this particular section, you can see that both compound has merged with each other by making one bond and donating one electron to each other. So now you can see that both have joined together with this particular bond shown by the red line. This is nothing but the termination step, in which two growing chain of polymer comes together and join with each other by donating one free radical or what we call as a free electron. In this manner, we can actually arrest and we can stop this polymerization process. So this was the first method by which we can achieve termination. Now in the second method, what we do is, you can see here, one hydrogen atom of one growing chain joins free electron of another chain and stabilize it by forming double bond. So in the second method, we try to make double bond out of it. So now with the same example, we can understand the second method as well. You can see we have taken same compound that we have used in the previous example. Here is that compound and here is one more growing polymerization chain. So when both the chain come together, this particular atom or this particular component will donate its electron and that electron will combine with this one. And this hydrogen will link with it. You can see here in this particular section, we are producing two polymer out of these two chains. Here you can see that one product is having hydrogen as this CH2. Here you can see that here we were having only one hydrogen, but now after termination process it will have CH2. That means one hydrogen is added to this particular polymer and we have satisfied its free electron. So now this free electron has now moved from here to here. You can see that this carbon now will make double bond. You can see here in this image that it is making double bond and it is satisfying the all valency of the carbon atom. You can see that we are producing two polymer out of this chain. In first polymer, we are making the last component and we are adding one hydrogen to it so that this carbon will be satisfied. You can see that this carbon is making 4 bond. 2 bond with these 2 hydrogen, one with this compound and one with this X. So we can say that this polymer is now satisfied. And in the another polymer where we are actually donating electron, in which you can see that this particular carbon is making double bond with this element. So we can say that this donated electron makes the double bond and then one bond with this hydrogen and one bond with this X. So we can say that all the 4 valency of carbon atom is now satisfied. So with the help of second method in the termination, we can actually produce two polymer of different molecular weight. You can see that here this particular polymer will have 2 hydrogen and this particular polymer will have 1 hydrogen. So their molecular weight will be different. So this is what do we mean by the termination step. In termination step, we try to kill the propagation initiated by the monomer by adding some external compound that we called as inhibitors that we'll understand in upcoming session. So we can see that in the termination step, whatever product is forming, it is not having any free radical. So it cannot undergo any further polymerization process. You can see here this particular compound is not having any free electron or free radical. Again, this compound is also not containing any free radical. So now even if some monomer will come in contact with this element, it will not undergo polymerization process because it do not have any free electron so that it can make bond with another monomer. So having said that, now let's just move to the next point, that is inhibitors. Well, inhibitors are special kind of a compound that are used to kill or to arrest this polymerization process. You can see on the screen that inhibitors are chemically substance capable of killing polymer chain growing by combining with active free radicals and form either stable or interactive free radical. So we add this inhibitor in the polymerization process when we believe that the desired conversion is being achieved or yield that we need to produce is being achieved by the polymerization process, so that we can arrest or we can stop this polymerization process. So that we can say that this inhibitor combine with all the free radical present in the polymerization chain and stop this polymerization process. Normally, inhibitors are added towards the end of the polymerization process so that we can stop this polymerization process when the required conversion is being achieved or the yield is being achieved. They kill all the free radical and stop polymerization process. Here are some of the examples for the inhibitors such as hydroquinone, nitrobenzene and dinitrobenzene. These are some compounds that are used to stop or to arrest this polymerization process. Now, having said that, let's move to the next type of the polymerization process, and that is ionic polymerization. Well, we have already said that this addition polymerization process has a 3 types. The first one is known as the addition polymerization process. Then we have second one as the ionic polymerization, and the third one is the copolymerization. So now let's understand what do we mean by the ionic polymerization. Ionic mechanism of the polymerization process also involve attack on the pi bond by the electrons. But this attack is not being done by the free radical, which was the case in the free radical reduction, which was the case in the free radical polymerization process. So what are the compounds that attacks on the pi bond? Well, in ionic polymerization process, ions are mainly responsible for the linkage of the different monomer together and forming long chain of the polymer. So you can see that in ionic polymerization process, the attack is being done by the either positive or negative ions of different compounds. So now you can think that when one proton can attack on the pi bond and it transfer its positive charge to the further end of the carbon. To understand this, let's just consider this image in which you can see that we are having one proton like this. Here we have one proton which is in a contact with the monomer, what we call as the ethene molecule. So you can see that this ethene has a double bond carbon. Here you can see that this particular line shows the sigma bond, and these two dots are nothing but your pi bond. As we have said that pi bond is not actually bond, but it is just a cloud of electron. So when we supply sufficient amount of energy, this pi bond can easily break out. So when this proton will come in a contact with this monomer, it will transfer its positive ion. You can see that this positive ion will attack on this double bond, and it will break this double bond specifically on the pi bond, and it will make one single bond like this. You can see that here it was having only CH2, but as this hydrogen is being attacked, or this proton is being attacked on this particular monomer, it will form this CH3 compound. And again, this charge which was having with the proton molecule is now transferred to the carbon molecule like this. So we can say that we have produced this CH3 bond CHX plus one ion. This particular ion shows that now this monomer can undergo a polymerization process. So this is what do we mean by ionic polymerization process. You can see that this proton makes sigma bond with monomeric unit and polymer chain growth is initiated. So again, in this polymerization, we will also have three different steps. One as the initiation, then it will contain propagation step, and lastly we will also have termination step. We will understand all these three steps in a sequence in upcoming videos. Now let's understand this ionic polymerization process with one more example of the carbon ion, or we can say that carbonium ion. You can see that in this image we have one carbonium ion which is like this. It has plus one ion on the carbon atom, so it can easily donate this plus one ion to another monomer, and it can be easily linked with it. So this is what the actual case with this particular example. You can see that we have one carbonium ion which is in contact with the same monomer which has double bond. Particularly this is the sigma bond, and these two dots are nothing but your pi bond. So when this ion will attack on this monomer, it will form sigma bond like this. You can see that here we have formed one sigma bond, and you can see that this charge is now transferred to the last carbon atom. Same as the previous case, we were transferring free radical to the last carbon, but in this case we are transferring ions, that is positive ion or the negative ion, that we call as the cation or anion. So in this ionic polymerization process, we transfer ions from initiator to the last carbon of the polymer chain. This is what actually we are going to do in this ionic polymerization process. Now we will understand what do we mean by initiation step in this ionic polymerization process in upcoming videos. Till then, keep watching, keep learning. Thank you.